In part one of the video on the Southwest Technical Products CT-1024 video terminal, we'll be looking at the series of our radio electronics articles that kind of went through the construction and some of the ads, etc. for the unit. This device dates from the mid-70s. It was a build-it-yourself video terminal. There's several cards involved in it. This computer cursor, this is the read card, the UART card, the memory card, and the power supply. So anyhow, with that introduction, let's jump in. So in this video, we're going to be taking a look at the TV Typewriter 2. This is a terminal that you could build yourself from the mid-70s, and there was a series of articles in radio electronics. You can see here it's February 75. That went through the terminal, the construction articles, etc. This was a product that was produced by Southwest Technical Products Corporation, and you could buy the kit from them. They also produced computers based on, I believe, the 68,000 processor. So I thought we'd start out by taking a look at actually the magazine pages here and kind of what this is. And as it says here, it's a computer terminal. In February 75, the thought of having a computer terminal in your home was absolutely amazing. Actual computer terminals were extremely expensive. People were still using teletypes, those kinds of things, for input-output. So an actual terminal that used a CRT display was just an amazing thing to have, and to have it available at the hobbyist level was just remarkable. There's an ad here for it. Hopefully this somewhat shows up. There's the unit here with some boards in it, the keyboard. You can see a bit of the main board here underneath the keyboard. It came with a metal box that it mounted into. As it says, displays up to 16 lines of 32 characters at one time. It's got 2 pages capacity, each of 32 characters by 16 lines. It uses plug-in circuit cards, as it says, to lower possible cost and to somewhat configure them. It outputs standard NTSC video. So, a modified television set could be used, or a video monitor. It's using 2102 static RAMs, which were very expensive at the time. Remember, these are prices in 1975, so it was $175 in 1975. I don't know what that translates to now. A lot more than that at this point. So anyhow, there's a print article from the magazine. Other side of the article was a advertisement for the MITS Altair 8800 computer. Typically back then, if you bought a computer kit, you got a box with a small amount of memory and a processor and switches to be able to enter programs. Basically, you needed to add cassette tape or whatever for mass storage. And there was, the only input-output here in this configuration was LEDs and switches. So to be able to add a character terminal to a machine like this, just where it would plug into a serial port on the machine, was remarkable in the home computing scene. A little bit better view of the system here. There's the main board down below, and this happens to be the SRAM card with the 2102s plugged in here. I believe that's the cursor control board. No, I'm not sure what board that is. Parallel ASCII keyboard, plugged into a connector here, power supply in the back, etc. But very much a homebrew thing. As it says here, after seeing the overwhelming response shown for the TV typewriter story found in September 73, Southwest Technical Products went ahead and developed this. The TV typewriter was Don Lancaster published a book called The Television Typewriter, which was a completely different system for basically getting characters onto a television screen. And I just can't say it enough. In the home market, this was an amazing thing to be able to have at home at the time. Get a quick view of the schematic here. It's pretty much standard TTL logic. There's no magic here. Your expenses were really with the RAM memory, with the character generator ROM. Go back. See the character generator ROM here in the schematic? I really don't. But you know, of course, at the time, TTL logic wasn't cheap. It wasn't super expensive. But, you know, built from pretty standard stuff. 2.25 volt video pulse, 1 volt sync. You know, pretty standard stuff. Input 7-bit parallel ASCII. There's a page select ability to select one of the 2 displayable pages. And then you can move the cursor up, end of line, end of frame, cursor on off, line feed, character turn. An adjustable left-hand margining positioning. There's a pot that'll move the video position around, an adjustable character size. I haven't actually explored that. There's a manual cursor control board that would give you a set of switches you could use, and you could push a button and have the cursor move up a line or down a line, etc. You know, it's a very, I'm not going to call it a dumb terminal, but you know, it's a very simplistic terminal. You know, so there's a nice introduction here. Tells you that you can order these things from Southwest Technical Products Corporation. So it's pretty amazing. Let's move on to the next month here. So in March of '75, they continued the build article, and here it is again. It's a computer terminal, build it. Let me actually minimize that. It's a little distracting there. And it continues the article on about, you know, it gets into theory of operation, how it works, some of the logic decisions. This was typical in the area, so you'd get the printed circuit board layouts in the magazine. And typically, if you really wanted to produce your own boards, you would have to take pictures of these. Blow those pictures up to the size of the board, you know, expose a piece of film at that size, put photoresist on a blank printed circuit board, lay your photograph of this on top where you know you have clear where the light's going to come through and black where it's going to be blocked. You're going to expose the board, you're going to develop the board, and then you're going to etch the board and acid remove the unused copper. And doing this with a double-sided board was a little bit tricky because you basically had to expose both sides and etch both sides at the same time. So you had to make sure that, you know, the alignment was good. So it was quite an exercise back then of getting a printed circuit board produced by yourself for this. It was just often cheaper just to go to you know, the kit builder and get the boards from them. There was no downloading a set of Gerber files and uploading them to a printed circuit board house like we have today in a 3-day turnaround. This was a long manual process. 75, 76, I would have been in high school, and we had a photo lab, and we had an electronics lab, and we were making our own printed circuit boards. Even with a decent set of tools, a board the size of this and double-sided would have been a challenge. There's some add-on cards here. This card holds the 6 SRAMs. Again, it's a double-sided load. So memory. That's interesting. Oh, I see what they've done here. You've got the front and back layouts here, and then you've got 3D views through, so you're seeing both layers together. So same kind of thing. If you wanted to produce the memory card, you need to take pictures of this, blow it up to the proper size, expose a PC board, etc. Rather painful. So let's go to the next article in this series. Nice colorful cover here. They're still pushing the TV typewriter final details. You know, this was a big thing, and I suspect they sold a lot of magazines because of this. And somebody playing with prototyping boards. We move on to the next part in the article, and it continues on. It's got more theory of operation here. It's got a through the board view, so you're seeing the top and bottom layers. An X-ray view with a double-sided. So why they reproduced a foil pattern here, I don't know, unless there was maybe a revision. Oh no, this has got the component layout on it. So in this case, it's not meant to be a PC board layout because it's actually got there's IC23 there. So I think this just expanded a bit to show you where all the parts go. So essentially a silkscreen layer. Gets into memory ICs. It uses Molex connectors. So you've got, as you'll see in the video a little later that I shoot of the unit, you'll see these connectors. It uses these very old school Molex connectors. Article continues on. You can see some interesting kits here, and this is again from, I don't remember, April 75. So you could, order a kit to build your own function generator. And you could buy ICs. You could get a 555 for $1.10, a dual 555 or a 556 for $1.85, PLLs. Back then you ordered parts out of magazines. Superbuys famous make new jobber box tubes. So you could still buy radio tubes at the time. It was just a very different world. It was a lot of fun. We, of course, didn't have the internet then, so I couldn't just jump on Google and do a search and find as I did these articles. These pictures here I'm showing come from Michael Hawley's site. He's got a really nice website, a lot of SWTPC information up there. He's got several of these television typewriters that he's restored. He's got some beautiful stuff, and he gave me permission to go ahead and pull these photos off his page and use them. Manual cursor add-on for the TV Typewriter 3. So now that we have our TV typewriter up and running, we can add a manual cursor board to control the cursor with push buttons. Same thing here again, printed circuit board layouts. Schematic, 3 of operation. This gets into the interconnect. You'll see in a little bit and later in the video that there's a motherboard with most of the logic on it, and then a bunch of pin headers that these add-on boards plug down into. The world's smallest scientific calculator. It takes about 3 hours to assemble and only $30. It's a Sinclair. I actually had this calculator. Bought the kit and built it back in 75, 76 and used it. It was a fun little calculator. Couldn't afford like a real nice high-end HP. Now let's move on to the next bit here. Hopefully you're starting to kind of get a feel for this. We've gone from February 75, now we're to November 75. And we're on to the next article. And it's the screen read board. So, we're not a full year in here. We're like 10 months into articles getting out of the screen read board. You can manually position the cursor. Manual cursor, that's not screen read. Oh, there seems to be a... Seems to be an issue here. A problem. Those are labeled November. I expected this to be the screen read board, but it's the manual cursor board. That's funny because that's not what the cover said. Magazine issue, maybe? Let's get to April 76, the final article in the series. Typical bench. I mean, somebody who had nice equipment, typical bench. Probably a dual channel oscilloscope. Notice there's no BNC connector here. It's just using banana plugs. It's going to be a few megahertz. It's like a frequency counter, a bench power supply, probably B and K based on the way it looks on the front. Maybe not B and K. I'm not sure what this is. It's got a couple of meters on it. There's a CB radio sitting here. No idea what this is. This one actually had a baud to ASCII converter and serial interface for the TVT2. So I'm assuming maybe you could use that baud to ASCII converter to drive this thing if your encoding wasn't ASCII. Serial interface. This is really the heart and soul of the thing. So a full year away from the original article, and we finally have the UART board so that we actually can have serial data in and out of the thing. You had to be patient with large builds like this. Schematics for it. The artwork for the PCBs, you would have had to, again, take pictures, blow those up to the correct size. It's double-sided, all those hassles. And kind of gets you through construction of it. Depending on what boards are plugged in or not, it acts different ways. It's quite interesting. Machine language programming for the 8008. Not the 8080, the 8008. The predecessor of the 8080. So here's a book you could buy for $20. Setting up parity, odd, even, no parity 8-bit, etc. So some configurations. Based on what I've read, the serial board would do 110 baud. Without some modification, there was extra footprints on it, and if you wanted to go higher, the max was 1200 baud, I believe. You could add a crystal and some additional components and push it up to 1200 baud. Super fast. We've kind of taken a peek here through the articles. I don't know if there was anything else that I grabbed off his site to look at or not. I think this again is just that article we started with. Here's this great kit. Here's what it costs. Order them by the pieces. You even got a keyboard kit from them, a 53 key keyboard kit that you put together yourself. So, there's a quick look through radio electronic articles from February 75 to April 76.